All right, now we're ready to start talking about Nyquist, which is the programming language we'll be using throughout the course. Nyquist is a system with a number of different layers. This is a compact diagram that shows the operating system at the bottom on which everything is built. On top of that, basically we have the Nyquist language written in XLisp, which is another programming language, the SAL language, which is built on top of XLisp and actually written in XLisp. That's Nyquist, and then on top of that we have the Nyquist IDE, or Interactive Development Environment, that gives you access to all of that. It's kind of like a stack of pancakes. There are many layers, and this is how software systems are built. Looking at this top-down, when you first come to Nyquist, you are presented with generally the Nyquist IDE. This is actually written in Java, and so it requires the Java runtime, which sometimes you have to install to get Nyquist running. The Nyquist IDE is really running as a separate program from Nyquist proper, the programming language, and the two talk to each other through sockets. Generally, you're going to be programming in a syntax or a dialect of Nyquist called SAL. We'll get into that. SAL is actually written in XLisp, which is another layer. XLisp is an interpreted language. The interpreter for that is in turn written in C, and of course C is compiled into the instruction set of your computer, x86 64 architecture probably. But there's even more to Nyquist than that. XLisp has been extended with signal processing primitives, and there's a little language to help implement or specify the signal processing. This is compiled into C by a special program, in turn written in XLisp. And still more, within Nyquist, we have a score data structure that we'll learn about. And these are like little programs. They're actually interpreted by a built-in program that calls on XLisp to evaluate expressions that are embedded within scores. So there's a lot to learn here, but starting at the basics, Lisp and SAL are both interact with the user using what is called a read eval print loop. It's very simple. You've probably come across this in other languages, Python, for example. The idea is you enter commands into SAL. SAL reads the command, that's the read part. It compiles it into XLisp, and XLisp evaluates the commands. That's the eval part. And then anything that is returned from the command, a result, is printed. Now, not everything in SAL actually returns a result that gets printed, so there's that exception to the read eval print cycle. And also, the evaluation of an expression in SAL could result in a sound being played, and so there's another way to get output. But here are some examples. I may not do all of these, but let's switch to Nyquist right now and make some sound and do some programming. So my first example is play pluck of C4. And what this is doing is calling on a built-in function called pluck, which uses a very simple model of a plucked string, and the synthesized sound is played using the play command. Another thing we can do is load some code. This is a piano synthesis library, and Now that we've loaded that, we have access to some new functions. One of these is piano note, and we'll play a low note for 5 seconds. Now this is not a recording of a piano, this is actually a synthesized piano using a synthesis model that was developed by Jim Beauchamp and his student. Now I'm going to play a sine tone at middle C with OSC C4. Now let's talk about what I'm doing here. I'm typing commands into the upper left box, which is the text entry box for Nyquist. Everything I type gets echoed down below. This is the TypeScript or the console output of the Nyquist system. Down here, the SAL prompt indicates that we're using the SAL dialect. Here's the command that I typed, and then there's some output that's generated mainly because the play command is playing sound, and we get some information about where the sound file was written, the total number of samples, and some other information. Okay, let's take what I just did, and on the Mac, I can do Command P and retrieve the previous thing that I typed. In fact, I can go further, type Command P again, and go back to that piano note, or Command D for down, and go in the opposite direction for this history buffer. On Windows, I believe it's the Control key rather than the Command key, but these operations exist. Okay, so here's the last thing that I did, but now what I'm going to do is modify that by multiplying by another sine wave. So this is 2 sine waves multiplied together, and you can imagine what that sounds like, or try to, and then let's hear it. Wow, we got a much higher frequency. We'll try to explain that later, but for now, let's move on. We're going to use another primitive called noise, and let's just play the noise by itself. Okay, so you notice that it came on very suddenly and it ended very suddenly. Let's do something a little different. We're going to multiply that noise by an envelope with a number of parameters, and again, we won't get into all the details right now, but these parameters are specifying the exact shape of the envelope. And now when we do this, okay, you can hear that it has kind of an amplitude shape to it. So those are some examples of running Nyquist. Let's talk about some SAL commands. The first one I want you to learn is the print command. You type print followed by an expression, and that means evaluate the expression and print the result. Pretty simple. Most languages, you might just get away with typing the expression and it would automatically print the result. But in SAL, you must you cannot just type an expression alone. You have to prefix it with a command, so we use print. The second command I want you to learn is exec. So exec means execute or evaluate the expression, but don't print the result. Pretty simple. So if you just want to evaluate an expression, use exec. The third one is, which is the one that we've been using, is play expression. And this works when the expression evaluates to a sound and it just causes the sound to be played. And finally, yes, of course, SAL has variables. And so The way that you do variable assignment is with the set command. You say set variable equals expression, where the expression is any expression that computes something. Again, notice the syntax in SAL is always you start with a command name followed by something. Most programming languages don't have this command name. So for example, in C, programming language, or Java, you could just write variable equals expression without the set. But notice that in those languages, you have to follow the command with a semicolon to say we're at the end. It's just a different kind of syntax. It takes some getting used to, but I think it's simple, and I think you can handle it. I know you can handle it.